Your eyes and your vision are under attack. Damaging blue light from the sun, your phone, your computer, your tablet, even light bulbs and car headlights is constantly bombarding you. The good news is our eyes actually already have a line of defense to counter the effects of blue light. This defense is made up of 3 pigments called carotenoids. MacuHealth with Micromycel, the only supplement with the exclusive patent on all 3 macular carotenoids and Micromycel technology.
With more screen usage and indoor time, myopia, also known as nearsightedness, is increasing and getting worse in children. Now, certified eye doctors can prescribe MySight One Day, the first and only FDA-approved soft contact lens to slow myopia progression in age-appropriate children. Visit CooperVision.com to find a Brilliant Futures certified eye doctor near you.
OIE Broadcasting is the emerging leader in social media. We use scientific entertainment to drive more patients into your office. Visit OIEBroadcasting.com and sign up today.
Hello and welcome to the Open Your Eyes podcast. I'm Dr. Kerry Gelb, the host of the documentary Open Your Eyes. If you're new here and you like our interviews, press like, subscribe, share, and hit the bell to get notifications of great new interviews. Also, please leave comments. Great news, you can now watch our full-length documentary, Open Your Eyes, on Amazon Prime, Apple TV, iTunes, Google Play, and YouTube movies and shows. Everyone wants to live a longer, healthier life. Scientists from around the globe are now studying why we age, if we could slow it down and even possibly reverse it, with the ultimate goal, extending aging while staying healthy. Today's guest, research scientist Dr. Mark Bartlett, is an innovator in the field of anti-aging, health, and wellness. Dr. Bartlett has a PhD in immunology, where he studied plant-derived compounds for their ability to inhibit graft rejection and cancer metastasis. Dr. Bartlett was involved in the development of many common targeted health products, including supplements that focus on mitochondrial health, healthy aging, and healthy metabolism. Dr. Bartlett, thank you for joining me today.
Pleasure. It's great to be here. Thanks for letting me share some of my thoughts with you.
I'm so excited really to have you and, to have somebody that, I love nutrition. I love the field of anti-aging and, I study it quite a bit. I'm very interested in the whole field of sirtuins, AMPK and mTOR, which we're going to talk about in a little bit. But I want to start with 1 in 8 Americans are metabolically unhealthy. So if you could start with that and what micronutrients are and what vitamins are.
Yeah, great. So, when you talk about anti-aging, you might think, wow, that sounds like a complicated science. Is there much that we can do? I find it fascinating. And I think that there are some very simple and practical steps that you can take to help yourself to age more healthily, have a good health span. And I think it does involve, from the very basics, hygiene. And then, I love to talk about micronutrients. I'm an immunologist rather than a nutritionist, but I'm just fascinated with some of the stories there. And then metabolism as well. And I think that they kind of build on each other. Metabolism is super important, but what it really is, when most people think in America, what is metabolism? I think, Dr. Gelb, you've probably sort of seen the same thing. We are so obsessed with weight management in this country that people really boil it down to this. If you have a fast metabolism, that means it's good because you're losing weight. And if you have a slow metabolism, that's bad. You must be getting older, so you're sort of gaining weight. So we really have to redefine for people what is metabolism. And metabolism, really in the biochemistry sense and in the nutritionist sense, is all of the chemical reactions that really make up the chemistry of life. And it's an incredibly complex sort of circuitry of reactions. And really, it boils down to these enzymes that catalyze each of those reactions of life. So can we start with nutrition a little bit, with micronutrients?
Please. Please.
So, I talk a lot, even in seminars with doctors and healthcare professionals. And the first thing I often ask is, well, what is a vitamin and what is a mineral? What do they do? And Kerry, you'd be really surprised at the awkward silence that happens. And they're scratching their head and thinking, wow, it's been a while since I had to think about that. That was high school biochem or first, biochem 101. So I remind people that every vitamin, every mineral is really a cofactor. That's how it works with the body. It's a cofactor for the enzymes. So you have all this genetic material, right? You have the DNA. Every gene codes for a protein. Usually it's an enzyme. And an enzyme is kind of a globular sort of string of amino acids that folds in a certain way. And it has an active site. Think of it like a Pac-Man. And its job is to catalyze a reaction. Maybe it's a chain of reactions. So you have a chain of these enzymes to build, say, vitamin C, which we can talk about later because humans have lost the ability to make vitamin C, but many animals can still make it, right?
Yeah, so, like dogs. Dogs can make vitamin
right,
C.
Yeah, that's exactly right. Guinea pigs don't, but a lot of other animals do. So here we have this, your body has done its job. You've created the enzyme. The protein is folded correctly. And in the mouth of that enzyme, you need a cofactor because it's catalyzing a reaction. A molecule comes along and maybe it's splitting that molecule. That's part of that chemical reaction of life. If it doesn't have the cofactor, it doesn't work. The active site doesn't work. So vitamin C, the B vitamins, magnesium, zinc, all of these things that we call vitamins and minerals are essential. We have to have them and we get them from our diet. And if we don't have them, then that enzyme doesn't have teeth. It can't catalyze the reaction. And there are some wonderful stories. And this is really what got me interested in science in the first place. Coming from Australia, we learned a lot about Captain Cook and how he discovered the east coast of Australia. And he was this marvelous explorer. And, he and his men hopped on this relatively small wooden boat and sailed around the world and, went to Hawaii. And we know that those sailors got sort of the pirate's disease called scurvy, right? And, so what is scurvy? Scurvy is a nasty disease where the body has lost the ability to sort of fold collagen correctly. So you can't build collagen without vitamin C. So vitamin C is simply an enzyme in that sort of chain of chemical reactions catalyzed by enzymes to create the collagen. So what happens when you don't get collagen? You just get nasty kind of conditions, right? Where you have lost the structural integrity of, say, your gums, so your teeth fall out. You've lost the structural integrity of the blood vasculature because obviously the blood vessels all have collagen to sort of hold things in place. So you've lost all of this structural protein.
And you start bleeding and bruising easily.
Yes, exactly. So it was around the time of Captain Cook that they did actually know that there was a correlation between sort of greens and vegetables and getting scurvy. So on the before Captain Cook sailed, his doctor, the surgeon on his fleet, David McBride, said, "Okay, what you need to do is take this on board with you." And he sent them this new method for treating scurvy at sea, and he gave them sort of barrels of malt. He gave them some bottles of lemons. He gave them some sauerkraut and some soup and things like that. And it was really interesting that, very quickly, if the surgeon was really careful on the slightest sort of symptom of scurvy, he would make sure that they sort of had the lemons. But meanwhile, they had to also eat this other food. And I was really fascinated by this, that Captain Cook's sailors did not get scurvy. I thought it was a brilliant breakthrough. But writing just before his death, James Cook complained that every innovation, whatever, though ever so much to their advantage, is sure to meet with the highest disapprobation by seamen. So he said the portable soup, the sauerkraut, were at first condemned by them as stuff not fit for human consumption. So even though it was saving their lives, even then the sailors complained about this regimen that sort of helped them to stay alive. And has anything changed in the last couple of hundred years? I'd venture to say maybe not. We still complain, don't we?
So yeah, they had the limes, so they were called limeys.
That's right. Exactly. They were called limeys for that reason. So I thought that was fascinating. There are some really interesting stories in this area of nutrition. And there's one in the modern day that may be even more fascinated and related to aging. So when you think of vitamins and minerals, you don't think of them as sort of an anti-aging strategy. But Dr. Bruce Ames, who I'm sure, Kerry, you've heard of, a famous scientist who invented the Ames test, right? So he's sort of more of a genetics focus, and he's talking about genetic stability. The Ames test, for our viewers who may not recall, is simply a way of testing nearly every additive in our diet. You can have a petri dish full of bacteria. You might apply the food dye or the hair colorant or the food stabilizer, whatever it might be. And then Bruce Ames in his test would look for sort of instability in the DNA of those bacteria or mutagenesis, right?
To see if they're at greater risk of cancer.
Right.
And he found with the hair dyes, and he found stuff that was put on furniture that would increase the risk of cancer.
Exactly. So I'm super excited that you're familiar with that story, because just using that simple test, he found, for example, that a very common well-used hair dye was causing DNA strand breaks in the bacteria, causing mutations. And he said, well, what this indicates is that it may cause cancer. And he actually had that hair dye removed from the market. So it's a brilliant test, a very cheap and easy test. So he really turned a little bit to nutrition in his later years. And he had a scientist join his lab, Jim McGregor. And Jim McGregor was a toxicologist. What he was interested in is what happens when you irradiate animals, what happens to the DNA. And he did this beautiful series of experiments that really fascinated Bruce Ames, of course, because he was interested in genomic stability. And one day, so he's irradiating mice, right? And he has control mice, and he's looking at where the DNA strand breaks are and how the cancer is forming. And one day, Jim McGregor comes into his lab and he goes, who the heck has been messing with my experiments? All of the control mice now have got DNA strand breaks. And of course, the postdocs and everyone are like, we didn't touch it. I swear, these guys have not been near the cyclotron. So he did some investigation, and he discovered that the provider of the animal food that was giving him the vitamin mix for the animals had forgotten to put in folic acid. How interesting is that? So he did sort of a titration or a dose response experiment, and he discovered that, yes, if you don't have folic acid in the diet, the animals will die. So how much, as you go from sort of the daily value down a little bit lower, what happens? And he discovered, yes, you will get DNA strand breaks pretty much the same as ionizing radiation. This was an incredible breakthrough for Bruce Ames, saying, well, wait a minute, so these guys are involved in sort of one carbon sort of transfers. And, they sort of add 1 carbon units to thymine, which is part of the DNA, right? And so it's causing nicks in the DNA just simply because you don't have enough folic acid. And the enzymes that are cruising up and down the DNA and monitoring for strand breaks and nicks are unable to fix the DNA. So then he did another series of experiments. He has a different postdoc in his lab. And after a lot of thought, he realized that the body is kind of doing a triage. Like, why does the body do this? And as we've already described, the biochemistry of the body, all of those chemical reactions need to happen, and they're happening through enzymes. And those enzymes need the cofactors, the vitamins and minerals. What happens when the body is marginally deficient in one of them, in one of the nutrients? So for example, what happens when people don't get enough calcium or magnesium? I think most of your audience will immediately say osteoporosis, right? You just don't have the bone density because calcium and magnesium are super important for bone density. The reason, though, think about the reason why we suffer from bone density issues without calcium and magnesium. Most of us don't think about it in this term, but actually the body's doing triage, where it says, okay, if I'm to use calcium and magnesium for important systems in the body, and there are hundreds, what do I need to do with the calcium and magnesium that I do have? Should I use it to make strong bones? Or shall I use it for the thing that's going to keep you alive today, and that is for neuromuscular action, right? In order to survive, we need to be able to think, we need to be able to move. And calcium is involved in those nerve impulses and everything to do with that. So
that's the Bruce Ames triage theory, where you're going to protect today, but sacrifice later on.
Exactly. Yes. And so you can extend that to all of the vitamins and minerals. It's just a brilliant, it's a theory, but he's been able to do a series of systematic studies that show very nicely that it works. So he studied, selenium and all of these other nutrients. And so the take-home message is you cannot find yourself to be marginally deficient in any of these nutrients, because the body, sure, it will use those nutrients in short supply to basically catalyze those systems that are required today: movement, thought, all of those things. And, the same with DNA. If you are marginally deficient in folic acid or those B vitamins, where's the body going to send them? Well, the DNA, genomic stability, sort of takes a back seat to energy. And energy metabolism is completely dependent upon these B vitamins. They're part of the ATPase. These are the enzymes that are critically involved in extracting energy from the food that you eat, again, so that you can move, so that you can have fight or flight or hunt your food or run away from predators. So, the triage theory is really brilliant. The body is brilliant. So here you get now a trade-off between staying alive today and then growing to a ripe, healthy age, right? Because when you think about it, the dense bones, the genomic stability, those are the things that impact you in later life, may shorten your life, or certainly will impact the quality of life.
Bruce Ames talks about 40 vitamins, 15 minerals that you need to run your metabolism. Is 40 vitamins, 15 minerals, is that enough? Are there more? Are we going to find out more as time goes on?
Yeah, that's a great question. I think we've got to the heart of most of it. What's really interesting is that there are some that are really, obvious that you need quite a bit of. Calcium, magnesium, we're talking about, several hundred milligrams. And when you think about, one capsule of a vitamin is 500 milligrams, right? So if you're supplementing your calcium, it's a fair bit. But there are others that are in very, very small trace amounts, like selenium, which is actually more toxic than arsenic, but is actually essential. And even arsenic itself may be a cofactor that we're starting to discover. So, obviously we don't supplement with arsenic. We do actually find necessary, especially in some countries where selenium is deficient in cereals, et cetera, or manganese, that we need to supplement with them. So what's the take-home message? I really like Bruce Ames's thoughts on this, and I've talked with him personally several times. He says, just at the very least, get a cheap vitamin mineral supplement so that you've got like this insurance policy to make sure that you've got these micronutrients, so that your body doesn't have to make the choice, so that you can have your cake and eat it too, and be healthy all the days of your life. So it's a fairly simple thing. I mean, obviously the best advice would be to eat really healthy, but a multivitamin is a really good little insurance policy.
So the way food is being manufactured now, is there enough vitamins and minerals in our food anymore compared to what it was in the 50s?
That's a great question, Kerry. I know when I first moved from the NIH into this industry, where I thought maybe we could make a bit more impact, that was a very strong theory, right? Is that the carrots that you get today may not have all the nutrients that the carrots that your grandma grew. I guess that may be true. Certainly, things are treated differently, and we're, the growth of the vegetables is sort of on a mass-produced level. I tend to think more in terms of diversity. Like, when you think of a carrot, it's always orange. But actually, a couple of hundred years ago, they were orange, they were purple, they were yellow. We had a greater sort of biodiversity of the vegetables and the fruits that we ate. And this is what caused the problems in Ireland with the potato blight, right? Is they had limited so much the genetics of their potatoes that they didn't have any diversity when a disease came through and wiped everything out. And I think our body's the same. We need a lot of diversity in our diet. We have the opportunity in our modern times to eat better than the medieval kings. We can get fruits and vegetables from all over the world shipped in. It would be nice if we increased the diversity. And I think too, I do agree. In my own house, I grow a lot of my own vegetables. It's all organic. I sort of have this ecosystem where the chickens are being fed the scraps. They're creating the manure that goes to feed the vegetables, and there's less need for insecticides and artificial fertilizers. I think there's a role for it, but I like diversity, and I like natural sort of growth of the vegetables.
At one time, they used to put 52 minerals to help grow the vegetables. Now it's just NPK. Is that enough?
Yeah, I agree. Probably not enough. But plants, just like humans, need all of the nutrients, not just sort of the sum. They're probably doing their own triage, right? And that's kind of interesting too, right? Is that you grow the vegetables, and there's this. I'm not sure if you're sort of familiar with the hormetic effect, but
Yes.
let's say I live in Arizona, and I'm growing the vegetables.
Like weightlifting, with stress, we want to stretch the vegetables to make more polyphenols, and the vegetable makes more polyphenols. It's better for us.
Yes, exactly. So if I'm living in a really hot, dry desert environment and I'm growing my vegetables there and I'm eating them there, those vegetables are experiencing the same hot sort of sun and all of the radiation. They are then, their defense mechanisms create these polyphenols and carotenoids and other defense mechanisms that then we eat that become part of our defense mechanisms. So there's some sense to sort of keeping things local as well, isn't there?
So tell me about the EAR, the estimated average requirement, and the RDA, the recommended dietary allowance. Are those enough? What are they? And, we don't really use EAR. We use in the United States, really, the RDA. And, for a time, that's thought that may not be enough. That's just the minimum that somebody needs.
Right. Yeah, I certainly can't quote all of the numbers for you, but just in general terms, there is a real paradigm there. And that is that when nutritionists over the past few decades have calculated what we need, it's often generally the minimum that we require to prevent a deficiency disease. And in order to prevent scurvy, for example, you need about 60 milligrams of vitamin C. So it varies from country to country. I think in Australia, it might be 80 milligrams. Here it's 60, but the scientists generally agree that will prevent the deficiency disease that's really awful. And so you've got to get at least 60. But then if you look at the literature, you realize that, again, vitamin C is not a cofactor for only creating and helping to build the collagen healthily, but there are other systems in the body as well. So if you look at Linus Pauling, he looked at vitamin C and said, well, you need like 20 grams a day. It has all sorts of impact. Maybe I think the truth is somewhere in the middle. Certainly, I think 500 milligrams, something like that, is important because it's also an antioxidant. So it plays a huge role in other systems of the body, not just in the deficiency diseases. So, and you can really extrapolate that to a lot of the vitamins and minerals. That doesn't mean that we sort of need to mega dose, but again, those daily values are sort of a minimum requirement, I think, for the most part. And again, it's our responsibility. The take-home message is eat a diet rich in fruits and vegetables that's diverse, that has all these vitamins and minerals in them. And as an insurance policy, as Bruce Ames would say, take a multi. It's not that, doesn't have to be that expensive.
And how about bioavailability? How do we make sure we're getting these vitamins into the body so we could use them?
Yeah, that's really important as well. There's, you look at the way that things would normally be delivered into the body, right? Say iron, for example. The CDC would recommend for a pregnant woman to have 60 milligrams of iron based on iron oxide as a supplement. But we do know that, say, if you're eating meat and it's chelated with the heme molecule, you need less and it's easier on the stomach. There are some enterprising companies that have come up with chelated minerals, kind of started in the agriculture area, but now you can buy really nicely chelated iron where you only really need about 15 milligrams to get the same impact, and it's more gentle on the stomach. So yeah, bioavailability is super important. And it also is important in the way that we get our nutrients, the way that we eat. So you may remember, Kerry, back in the 90s, the devil was fat, right? Everyone's overweight because we're getting too much fat in our diet. And so the food industry sort of pivoted towards fat-free, and everyone, even fat-free salad dressing. And that, I think, messed up a lot of bioavailability type paradigms. For example, think of a salad that you're eating that's rich in carotenoids and polyphenols. Carotenoids, for example, are fat soluble. The vitamin E is a fat soluble nutrient. And, some olive oil, some real fat on that salad actually helped your body to help those carotenoids to be more bioavailable. And suddenly we're not getting all that we can out of the salad because we've sort of shifted erroneously, I believe, towards a sort of a fat phobic mentality. And there are other things that you can do as well. You might ask someone, well, you know, what's more bioavailable in terms of carotenoids, a raw tomato or raw carrot or cooked? And it's maybe not all that intuitive, but steamed carrot is going to be have more bioavailable carotenoids than a raw one. Even though, sure, I don't discourage you from eating raw, but you know, if you crack open those cells and make those carotenoids more bioavailable, then that may be helpful.
How about if you put it in a blender or you juice it? What happens then?
Yeah,
You know?
I do that all the time. I mean, every day I'm juicing kale and carrot and beet and apple, and so it makes it easier to digest, and I would think more bioavailable as well. So yeah, I'm a real fan of juicing.
MacuHealth, your science-born and tested solutions for visual performance, macular degeneration, and dry eye syndrome. New products coming soon. Embrace the science.
So are you a fan of juicing or blending or both?
Yeah, I think they're both serve the same purpose, right? My juicer macerates, right? So it's one of those old champion juicers that, you know, you shove the carrot down in there and it's got teeth on the and it just sort of grinds it all up. But juicing may be even better. I think in my macerating sort of juicer, I've got big holes, so a lot of the fiber gets through. And with blending, I think also the same kind of deal. You're getting all of the fiber, and that kind of I think maybe that shifts our thought towards then, you know, when you're thinking of bioavailability, when you're thinking of the GI, what I then think of is metabolism. So you asked that question before, who's metabolically healthy? And it's true that about in recent studies, about 1 out of 8 Americans is metabolically healthy. And again, what is metabolism? It's all those enzymes that we talked about, and therefore you need the micronutrients. So let's suppose that you've looked at Bruce Ames studies, you believe that triage is really important, you're going to make sure that you get all of those micronutrients. If you get all of those and there's no marginal deficiency, that's an ideal foundation for healthy aging, because now all of the biochemical reactions of the body, and there are tens of thousands of them, they're all going to be able to hum along quite nicely. You're going to be able to make the collagen, you're going to be able to sort of do everything that you need. So what then could disrupt that? And that's where we talk about some of these things that can sabotage our metabolism. And I believe it actually begins in the gut. So you think about this circuitry, it's very delicate, but there are some things that can disrupt it. And what we're seeing, you know, it's so interesting that since 1980, I think there's been a 5-fold increase in diabetes, which is really a metabolic disorder, isn't it? And it's leading to, you know, we should talk about glycation a little bit later, but that is an example of sort of a metabolic disruption. So wait, he's got all the vitamins and minerals that he needs. So why is there this metabolic problem? Well, it's because certain things can really interfere with the metabolism. And, you know, if I were to, you know, if we were to finish this podcast in 5 minutes, I'd cut to the chase right now and say, how do you fix that? Really, the best evidence is that a healthy diet and exercise, physical activity, will help to stabilize those reactions in the body. But we can't ignore the gut, you know, and I've got a picture of the gut sort of behind me here, right? I'm kind of obsessed with this. We have a situation where you've kind of got an inside-outside situation. The body, the muscles, the tissues, the blood are basically perfectly sterile. But you have this alimentary canal where you have, in the colon, for example, the most dense habitat for bacteria on the planet. And you've got 300 or 400 at least different species of bacteria, mostly beneficial, but there's this, you know, all sorts of stuff going on in there. And these bacteria have bacterial cell walls that have sort of lipopolysaccharides and things. If any of that gets past the gut intestinal barrier into the sterile portions of the body, all hell breaks loose, right? LPS is just, it will go through the immune system like a cyclone. You know, the immune system is going to be called to play, there's going to be inflammation, and that is a huge disruptor of metabolism. So there's all sorts of molecules now that are being characterized that if they get through that gut intestinal barrier function, they're going to cause metabolic disruption big time. So we really need to look after all of the bacteria on the GI side. Why? Because they actually, when they eat fibers and when they eat certain plant phytochemicals, they then excrete short-chain fatty acids. And those short-chain fatty acids like butyrate, those are actually the chief energy source for all of the cells that line the GI tract. So we have the villi, the microvilli. So these gastrointestinal cells have just an incredible surface area, about the surface area of 2 tennis courts. And in order for each of those cells to be healthy and plump and fat and cause a very tight gastrointestinal sort of barrier, these gap junctions have to be super tight, they have to be healthy, then you need to provide those bacteria with the nutrients that they need to stay healthy. So that's where the fiber, the diet that's rich in vegetables really comes in handy. And we're doing some more research these days. Our group has just published a few papers in the area of anthocyanins and shown that, the traditional approach is probiotics and prebiotic fibers. But we're also discovering that there are phytochemicals in nature, like the purple molecules that you find from berries or from even purple corn. They actually are like a superfood for the bacteria that help them to stay healthy, produce the short-chain fatty acids so that the gut epithelial cells are healthy, so that you don't get this disruption of metabolism.
Those are great points. I had a podcast with Alessio Fasano, and we spent the whole time talking about the gut and autoimmune disease and zonulin and how he discovered zonulin. So that's really a fantastic discussion. So look for that one. So I want to ask you go back to bioavailability, absorbing our nutrients. What do you think about, as people getting older, they have less acid in their stomach, and maybe do they need to take acid to help some people to help digest, or do they need digestive enzymes to help break down these vegetables?
Yeah, I'm not, the acid equation is pretty important. I haven't sort of focused in that area very much, but certainly in the area of the enzymes, generally, you're right, our body does produce enough, unless we have sort of a condition where we're not producing the enzymes that we need. Most people can get by, but there are some nice supplements on the market that sort of help in that area. I'm particularly interested in those, bromelain, papain, and some of these enzymes that do survive transit through the gut and help resolve inflammation. That's kind of a really interesting area. And, there's a product called wobenzyme that's been on the market for years and years, with some really nice clinical studies showing that it will sort of, in injuries like bruising or post-exercise muscle soreness, has an amazing effect. But it does actually go back to, there are a lot of people that believe that we should be eating more raw fruits and vegetables, right? And I actually think that there's some merit to that, because those foods eaten in a non sort of, they're not overly processed, they actually possess their own enzymes that help to break themselves down somewhat, right? So even brown rice with the lipases and lyases that are there, I think that, again, it sort of boils back to a healthy diet. And I've heard it said or read in a book somewhere that you shouldn't eat anything with a label. And I'm starting to really believe that that's the case. The more natural it is, the better for you. And it's going to help sort of balance the acid issues for bioavailability, the enzyme issues for bioavailability.
How about taking a digestive enzyme? You kind of alluded to it before you eat. And if you are going to take it, how far before you eat should you take it?
Yeah, that's not an area of my expertise, Kerry, but I've always believed that, for the most part, supplements should be taken with food. And that again helps with bioavailability, right? You're taking a supplement that has lipid soluble or water soluble nutrients, all of those things taken with food. It's going to make it much easier on your stomach and also make it more bioavailable, right? The vitamin E is going to sort of combine with the dietary fat and get in the carotenoids as well. Polyphenols are somewhere in between, right? Lipid and water soluble. But if you're taking an enzyme type supplement, I've usually recommended with food, although there's some papers that I've read that show that, for some of these sort of the anti-inflammatory type enzyme activities on an empty stomach would be good. So I guess you'll have to do your own homework a little bit on that, the guys in the audience, but there's some really good food for thought there.
So let's talk about some of the common vitamins and minerals before we go into the anti-aging arena. Let's talk about selenium and how it helps make DNA and helps us fight against infections. So we're talking about multivitamins and making sure you have the 40 vitamins, the 15 minerals. Let's talk about some of the big ones that we know that we have to have. Let's start with selenium.
Yeah. Well, I guess I really talk in very general terms about the necessity of those nutrients, right? It's really interesting to me that, again, in natural terms, they come from cereals, so wheat and other things. And I think in general in America, we don't have, the problem that they have in some areas, but it boils down to the fact that some soils are deficient. I believe it's in New Zealand, the soil is deficient in manganese. So, those countries really need to sort that out. We know that there are issues in China with selenium, right? In some areas where they were getting too much. So it's a balance. It really does.
Keshan syndrome, right? Keshan syndrome.
Yes.
They were actually getting too much. They were being poisoned by getting too much selenium. And then there are places where you're not getting enough selenium.
Yeah. So it really, I think it behooves sort of the nutritionists in the areas where we're eating the food and we have the certain soil conditions. They need to know sort of the unique situation in each part of the country or part of the world. I find that really an interesting thing. And there are certainly plenty of large surveys that have been done by, US Department of Agriculture and others. I think I find that's very useful. And, attend these meetings with nutritionists. Again, I can't pretend to be a nutritionist. I'm a cell biologist, but just amazing amount of work by incredibly dedicated researchers into every single nutrient, whether it's B vitamins, whether it's calcium, magnesium. Here's some really, again, Kerry, some really general things. When we invited recently a bunch of experts to come to our facility here, and we spent 2 or 3 days talking about the different micronutrients and how much we need and have things changed. And, if it's a B vitamin, should it be folic acid or it should be folate? So these experts came to us and they said, well, the first thing that we do in all of our work is look at our status, our vitamin mineral status. And in nearly every case, professor after professor would say, well, the status is low, that the average American doesn't seem to be getting quite enough. So, and I've attended these big meetings internationally where we have scientists come and talk about all sorts of nutrition and how pregnant women aren't getting enough, or women are sort of low in this area or that area. And here's the funny part, Kerry, is that we get to the end of a 2 or 3 day seminar, and then the audience will ask the question, well, then should we be supplementing? And the panel nearly always goes, whoa, it's way too early for that. We've got to do a lot more research. And I find that really interesting is that, I love these researchers. They're doing brilliant work. They're publishing papers. They're experts in these nutrients, but they're all quite conservative by nature. And they don't jump in and sort of immediately recommend supplementation, but just sort of standing on the outside as an immunologist, cell biologist, when I go to these seminars and I hear all of this work being done, for me, that's the natural place to go. For the average sort of layperson in the audience, they go, well, then if we are not, if you've proven that our status is low, what's the solution? And nearly always the nutritionists will say, well, just eat a better diet. And that really boils down to sort of the sailors on Captain Cook's ship, right? Where they just say, oh my gosh, but that's not fit for eating, or I'm too busy scrubbing the decks to eat a balanced diet. Right?
Well, we know 63% of the Americans are eating processed foods,
Yes.
Fake oils and too much sugars and processed wheat and trans fats. And so they're not getting the vitamins and the nutrients that they need to get. In fact, the USDA, I think it's like every 10 years, they measure Americans nutrition, and 93% of us are deficient in at least one, and about 17 or 18% are so deficient we're actually like killing ourselves. But I want to go back. I want to go back to you mentioned probiotics and prebiotics before for the gut. How do you feel about taking probiotics, prebiotics? What kind would you take? Or do you think eating fermented vegetables is enough to protect the gut? Because we don't want to get that intestinal permeability. We know that, as you said, there's 400 to 500 different species that helps keep us healthy. It helps us decrease, with the right species, decrease obesity, decrease diabetes, and many other types of autoimmune conditions. So is a probiotic, a prebiotic enough? Prebiotic being food for the microorganisms, microbiota, the microorganisms, or is it not enough? Do we need to eat fermented vegetables because the way we used to many years ago, but you can still buy them to get more of a diversity? I know it's a long and a complicated question. Not sure there's a real answer, but what, in your best opinion?
Yeah, for sure. No, I am just fascinated by the the things that we're learning now. We've got these new techniques now where we can really look at the biodiversity in the GI tract. We can sort of narrow it down to the genus and species and the hundreds of different bacteria that's in your garden. Some of the basic principles that I just find amazing is that everyone is different. So, my GI microflora, the garden there is quite different to Dr. Gelb's. There are on, 300 or 400 at least that we know, different species. Some are generally considered good and beneficial, and some are generally considered not. There's also amongst that, viruses and even funguses and all sorts of things there, right? So there's this garden. And so let's talk about probiotics. I think that there's an amazing role. We've got some really very interesting probiotics. One that I really like that I sort of helped bring to market from an Australian researcher is Lactobacillus fermentum. So the genus and the species, Lactobacillus fermentum, and then the subspecies or the strain PCC. And what's really fascinating about this strain is that it seems to naturally gravitate towards the Peyer's patches, which are these immune loci in the GI, and they therefore have a systemic effect. So they sort of seem to reduce inflammation. They've done studies with this particular probiotic and children with eczema. I mean, how weird is it that you can impact the bacteria in the GI and then therefore impact a sort of a skin condition, and even asthma and other things? And so what I learned about this is that that the talent of a probiotic is usually at the strain level, maybe not even at the genus and species level, but definitely at the strain. They have different impacts in the body. And I guess that's a sort of a good evidence that all of the different bacteria that are naturally in that garden in your gut are also sort of doing different things and helping the body in different ways. Whether it's PCC or some other lactobacillus or bifidobacterium that you use as a probiotic, here are the take-home points. One, is it robust enough to survive its time in the capsule or wherever it is on the shelf? And we have lots of companies that come to us and they say, this one's stable. And we'll say, well, we'll see for ourselves. And we have all sorts of stability chambers here, and we'll test them in a capsule, in a sealed sort of bottle, whatever it might be. The best conditions, you have to make sure that they're very dry because water is the worst enemy. And then we look at them after 6 months or after a year, and it's surprising how delicate they are. And generally you want them to be alive, or at least that's the theory. So maybe you start at 20 billion per dose. Is it going to be 20 billion at 6 months into its shelf life? So those are the things that you have to work with a company or a product that you trust. The next thing is, okay, is it going to survive transit through the acid environment of the gut? We're talking pH 2, maybe 3, and that's the hydrogen ion concentration is just massive. And so they're pulling apart these live bacteria. Will they survive transit down into sort of the large and the lower and the small intestine where they're needed? So that's another thing to look at. But ultimately, let's say you've got one that works. Then do you have to take it for the rest of your life, or can you take it and it's going to impact your health for good for a long time? And that is really where I believe that the research I see a lot of people that believe that it'll work forever. From what I've seen, it's always a transient impact. So it can be really good. And I would recommend it highly for situations where you're in a different country and you're eating new foods and new bacteria are being introduced and you might get sick. Maybe you've got some kind of a stomach bug. I think that the probiotics, a good one, can have an amazing impact on your health. But ultimately, your garden is set in its ways and it's going to want to return to wherever it was, whatever that makeup, whatever that biodiversity is. You can take a probiotic, but ultimately, if you stop taking that probiotic, it will return to its natural place. And so that's why I think there's a huge role for the prebiotic fibers. So we should be getting about 25 grams of fiber in our diet every day. There are some soluble, there are some insoluble, but ultimately, as I described earlier, they are a substrate. They're kind of a food that help the bacteria in the GI to be healthy. So I think it's the equivalent of adding a fertilizer to your GI. You really need this. And ideally, you'll be getting it from a diet rich in vegetables and fruits. But there are some really good fibers that you can use. They've done some more research in, GOS or glucooligosaccharides, some XOS, xylooligosaccharides, right? Where they seem to be sort of a potent super fiber where you only need a couple of grams instead of 25. And as a supplement to your diet, I think that they're fantastic. I highly recommend them. And then one other point. I mentioned earlier that the bacteria, the probiotic may die. This is a new area of research, postbiotics, where it seems that even a heat-treated, killed probiotic bacteria may have all the goods that it needs to help stimulate and to keep healthy the GI. So that's another area of sort of increasing interest right now.
Wow, postbiotics. I've never heard that before.
Yeah.
Yeah, explain that a little more.
Well, so what's going on? When you sort of talk, I like to sort of think back to Paleolithic diets. What humans kind of adapted to not getting food every time they wanted, sort of periods of fasting between meals, and eating sort of hunting and gathering. So you're getting a huge amount of diversity in the foods, and the meats that you're eating are wild, and therefore they've been eating ferns and lichens and grass. So the meat is rich in omega-3 fatty acids. So, and then maybe you're cooking it over a campfire and ashes falling into the food. And so you're getting a lot of stuff that's sort of keeping the immune system busy. It's sort of challenging the immune system. You've got all sorts of things that look like the bacterial cell wall that are getting into the gut that sort of cause sort of a yellow alert in the Peyer's patches and the immune cells there. So you're getting this really nice balance of immune surveillance going on. You're getting the fibers and things that you need. So what was the question again?
About postbiotics.
Yes. So you think of the bacterial cell wall itself. It's got sort of these structures that are gluco sort of polysaccharides and things. You've got lipopolysaccharides like LPS. That, as I mentioned before, as a cell biologist, LPS was the enemy. You're trying to culture cells and you're constantly aware of viruses, but especially LPS, because if, as an immunologist, if you're looking at immune cells and maybe you're studying T cells in culture, any hint, if those cells get a whiff of LPS, which is basically something that's in the cell wall of a bacterium, then they just go berserk. And, a lot of the natural fibers and things that you get actually look a little bit like the cell wall. That's why things like some of the medicinal mushrooms and things like echinacea work so well, is because they look to the bacteria in your body, to the cells in your body, the immune cells, like a bit of bacterial cell wall. And then that sort of maybe gets a macrophage excited. And the macrophage sends out all sorts of chemical signals, the interleukins, the tumor necrosis factor, all these things, the growth factors that then help to recruit and help other immune cells to sort of be on the ready. So, the highly processed diets that we're eating that are really devoid of any of these sort of fibers and phytochemicals and things that we really need to balance the systems of the body, not just the GI microflora, but also the rest of the body and the immune cells. I think, that's the problem with the highly processed diet.
It's 70 to 80% of our immune system is in our gut. I don't think people realize that.
Yeah, and it's huge. And a lot of people like to say that the skin is the largest organ. I usually take issue with that. I think that the GI is the largest organ. When you think about its surface area, you've got the villi, you've got the gut wall. And along the gut wall, you've got these villi, like fingers, that are designed to increase the surface area. But even the fingers have fingers, the microvilli. So you have this incredible surface area that's all designed to absorb the nutrients that we need. And every inch of that is covered in, mucins, and you've got sort of immune loci, like those Peyer's patches that I talked about, and then this sea of bacteria. And those bacteria are also on your skin. So, we're just starting to learn that, when we think of drugs and when we think of treating the body, maybe it's a metabolic disorder, whatever it might be, we always think of the organism, right? Us, what's this going to do to the human? We're starting to sort of move into a realm now, and it's sort of this postbiotic realm, where maybe we need to start focusing on the microbes. And I believe that food is the best medicine there. But think about, we are outnumbered about 10 to 1 by the number of cells of these bacteria that are in the GI. And so there's huge amount of genetic diversity there. And there's this relationship, there's this crosstalk. So now we're talking about this thing called, you've heard of Meta, right? Which is the parent company of Facebook. And I guess it's sort of to combine, the virtual world with the reality world, and it's both things. So now we're talking about the meta-organism, where we have to look at the human being as not just the organism itself, us, the human, but also this, on the skin and in the GI, all of these microbes. And there's this huge amount of crosstalk. There are small molecules that are crossing the gut that come from the bacteria. And so we have to consider now the meta-organism. And I believe that we're coming into a world soon where drug companies are going to say, oh, how do we influence these microbes? Let me give you an example. When you eat foods like eggs and meat and things like that, which I don't think are inherently bad, but lecithin, things like that, there's a precursor molecule there that the bacteria convert into something called TMA, trimethylamine. And then that is converted to trimethylamine N oxide, which sort of is a small molecule and can travel through the body and has implications in cardiovascular health and even heart failure. So why is that? We've got food that we need to eat. The bacteria are converting it into something that ultimately ends up, as the liver tries to excrete it, as something that's quite toxic and pro-inflammatory. And so that's an example of the meta-organism. And how do we treat that? There's some hints that there are some analogs from nature, dimethylbutanol, for example, that looks just like some of these, like TMAO. So it prevents sort of the formation. So olive oil contains some of this, or certain, virgin olive oils. So, drug companies are looking like, how do we slow down the production of TMA so that we can have the best of both worlds, get sort of the calories and the nutrients that we need, but not get this chemical crosstalk that may be unhealthy. So this is a new frontier, and I think we should keep an eye on it. It's very interesting, the meta-organism.
Before we move on from the gut, I think it's important that people realize that the bacteria in the gut make vitamins. They actually make vitamins for us. And, the more diversity that you have, the healthier you are. And you talked about eczema being helped from a probiotic. And that all brings us back to intestinal permeability and leaky gut. So it kind of does make sense.
Yes. Yeah, exactly. And it's fascinating also that this crosstalk, this circuitry that's happening between the GI microflora, the small molecules, and the body seems to also be impacting cognitive function. So, they look at autistic children and they show that the biodiversity of these microflora in the gut is much lower. And they do these fecal transplants, right, where you try to increase the biodiversity, and that has helped with the cognitive function of these children. So there's so much that we don't know, but it's just so fascinating. But, you think of things like TMAO, it's small enough to cross the blood-brain barrier. So it's affecting brain chemistry. Some are affecting mood. So there are more of these sort of happy chemicals and hormones produced in the GI, in the gut, than in the brain. So if you can impact the health of the GI, then you can impact mood. And that may also be a reason why some of the autistic children or others can have a positive impact from a healthy gut.
OIE Broadcasting is the emerging leader in social media. We use scientific entertainment to drive more patients into your office. Visit oiebroadcasting.com and sign up today.
Your eyes and your vision are under attack. Damaging blue light from the sun, your phone, your computer, your tablet, even light bulbs and car headlights is constantly bombarding you. The good news is our eyes actually already have a line of defense to counter the effects of blue light. This defense is made up of 3 pigments called carotenoids. MacuHealth with Micromicelle, the only supplement with the exclusive patent on all 3 macular carotenoids and Micromicelle technology.
Fitting multifocal contact lenses presents a big opportunity to meet patient needs while growing your practice. Alcon is your partner not only with our innovative portfolio, but through e-learning. Learn to enhance your multifocal strategy today with the Alcon Experience Academy.
Each generation was supposed to be healthier than the last one. Lifespan was supposed to be increasing. We were supposed to be in this paradise by now. Instead of getting healthier and healthier, it seems to have gone the opposite way.
Millennials were projected to be the first generation in history to not outlive the generation before them.
We are certainly headed for disaster.
I think a lot of people are beginning to question the whole story.
We live in a time where the paradigms are shifting.
And the optometrist, in my opinion, is one of the best kept secrets.
The public doesn't realize about going to the eye doctor. So many different diseases actually manifest in the eye. The back of the eye is the only place in the body that you could actually see the blood vessels.
Completely non-invasively, you could screen thousands of people, not just for their eye health, but for their whole body health.
Because this disease is here, it's also going to be here.
And I can look into the back of my eyeball, and there are expert doctors on the ground who are looking at my eyeball while I'm doing it.
The eye is the canary of the mind.
The eye is the kingdom.
Will everyone please open their eyes?
Since I bought Safe For You, my dad makes me clean his boat.
Es natural y es un buen producto.
Every time I go back to school, my mom always makes sure that I have my Safe For You products. I bring extra, and my roommates certainly don't mind.
It's a good thing I had Safe For You to clean up after this little guy.
When my hands get dry, I like to wash them with Safe For You.
And most importantly, the reason why I buy Safe For You is because it's safe for me and you.